talking about CrossFilter for the rest of the evening, which is a JavaScript library that helps you do what they call fast multidimensional filtering for coordinated views. And fast multidimensional filtering, okay, that makes sense. You have a big array of JavaScript objects and you want to filter it down based on some kind of user interaction. Coordinated views is the concept of having multiple visualizations at the same time on a page. And they probably visualize different dimensions of your data, and you want them to all sort of change in coordination. So that's the general idea. The presentation that I'm advancing on my phone with the cool remote control app apparently is not the same presentation that's on my computer. So if somebody else's computer is doing weird stuff. My name's Ethan Jewett. I'm a data management and visualization consultant. I'm also working on a project to develop a general purpose collaborative data management transformation and visualization platform. GPC, DMT, VP. If you have any better naming ideas, please let me know. You can find me at ESJewett on Twitter or on the internets. So this problem is a problem in the browser. If you get any significant amount of data and you want to do coordinated filtering on it with filters on multiple dimensions and different types of aggregations, it's really pretty tough. You have to keep track of all that stuff. You've got, I guess I just mentioned, you've got a lot of data. So even that in the browser can be a problem, like if you're trying to filter over large arrays. You've got filters, oftentimes multiple filters. So I want to filter on a dimension of gender, a dimension of country, and of decade. And I'll actually show you this app. There's a little demo in a second. So we have to keep track of different filters that the users applied at different times. We have to keep track of different aggregations. So like the SQL ones are here. There are more complicated ones. Sometimes you'll want to do aggregations over unique values across a different dimension. So we want to do something like the sum of all of the ages of people with a particular that have the same name. And so we'll have to keep track of all these different things in different dimensions. And we need it to all go fast. So we've got to have it be speedy. And I think we just got the impression from the last presentation that like a lot of these types of filters, a lot of these types of aggregations, especially if you're doing things like testing on strings, they can get pretty slow pretty fast. If we're talking about thousands, even tens of thousands or hundreds of thousands of records in the browser. So we need it to be fast, but we don't want to go back to the server to do our aggregations and filtering, because if we do that, we have client-to-server lag. So if you're trying to do an interactive data visualization in the browser, and you've got to wait for the request to go back to the server and then come back to the browser whenever you need to do a filter or aggregation, even if your server does it instantaneously, you're still going to be waiting a second or more for that feedback, which doesn't look too good for a browser-based app. It makes it look slow and a little bit hard to use. So I just wanted to show really quickly this application called, I lost it sorry, I lost the thing, but it's a kind of visualization concept that was created by a guy named Moritz Stefano, and the idea is that you're going to filter on. No, it's Flash, so this is a problem, and so you can't see it very well, but these are Nobel Prize winners, and you can filter on prize or gender, country, decade, or year that they won the Nobel Prize. And when you filter down, you get a little grid-based visualization of the people who won the prize. So this is what got me interested in the concept, because I saw this and I thought, you know, I should really be able to implement that in JavaScript. At the time, using ProtoViz, which was the kind of precursor to the D3 framework. And so I did it. I implemented it, and all the filtering that I did was pretty much what you might expect. It was array.filter and then the filter function. And so I had a little array of filters that I kept track of, what the user had applied, and then I filtered down the array of all the Nobel Prize winners whenever the user made a selection or took off a selection. And every time I did that, every time the user changed the selection, I refiltered everything. So even for a relatively small data set, that got pretty slow pretty fast. It was 2009, so browsers weren't as fast, but we were only talking a few hundred records here. So that obviously wasn't the solution. So I was thinking about it, and I thought, well, there's got to be a good way to do this, but I got busy, which was fortunate because somebody else did it for me. It was a very efficient way to approach the problem. So, just to review that demo though, what Moritz did in that Flash framework, which is pretty fast, was a situation where he controlled the data completely, so he knew exactly what the data set was going to look like. He did have many different simultaneous filters, so that's complicated. He had one aggregation type, which was to count people and display the count of people in each subgroup. So that's pretty simple. And he did it in the browser in Flash, which is something that I personally wanted to avoid. But that was the toolkit that he used at the time, and it was a toolkit that almost everybody used to do browser-based data visualizations at the time. That changed very quickly, but that was kind of the theory. So the question I had was, what would a general purpose approach look like? And what happened was somebody invented it, and they called it CrossFilter. CrossFilter was built by the people at Square, the payments processor. It was actually originally built by Mike Bostock, who built D3 on contract for them, I think. And then it was taken over by some people who work there. It's not highly developed at the moment, but they do take pull requests on GitHub, and there are links to it at the end of the presentation, which I'll post to the Meetup site. So the one key concept of a general purpose version of this was that it was going to be in JavaScript, because it needed to run natively in the browser, and JavaScript was getting faster and faster at the time, and now it's quite fast, and it's continuing to get a lot faster. So most focus, I think, on browser-based coding development and speed and optimization is focused on JavaScript at the moment, and so it's probably the place to be. It's also going to be important to encapsulate the data. So your data is generally going to be in a format where you have an array of JavaScript objects. The properties of the objects, date, value, color, are going to be more or less your dimension names, your column names. We'll get to that in a little bit, but that's the general idea. And then every object's going to have more or less the same structure. So some objects may be missing dimensions, or some objects may have extra dimensions, but the idea is, theoretically, the structure is always the same. And then, if you want to create a new CrossFilter, we have a global method, CrossFilter, and we pass our data object into that method. And we get a CrossFilter, which we're going to call transactions in this example. All these examples were coded without a net, so if you see any typos, that's because I haven't actually run them through a JavaScript engine, but we'll get to the live coding part later. So once you have a CrossFilter, you can define dimensions on it. So your CrossFilter doesn't automatically know about dimensions in your data. It could look at the object properties and try to figure it out, but the problem is that sometimes you're not going to want to use all the object properties, or you're going to want to create derived dimensions based on those object properties. So your CrossFilter has a method called dimension, and the dimension method takes an accessor function. That function takes an object from your list, from your array of objects, and it passes back a value. You'll note here probably that value that we pass back, we're going to cast to a string. If you want to, you can also cast it to a number, but you have to cast it to something because CrossFilter requires that the values in a dimension be naturally ordered. So if you pass back undefined, it will break. So always cast your values that are in your dimension accessors. Sorry. So in this case, we're defining a dimension based on the date property, but we can do it based on anything, and we'll see a few other examples of that later. So then we can filter on dimensions, which is kind of the point. We can create as many dimensions as we want, so we created one dimension in this case, and we're going to filter on that one dimension. And we're just going to filter to a string. I don't know internally if CrossFilter uses match, but hopefully it's using index of. So in this case, we're filtering to a string to a particular date. We have some other filtering options in CrossFilter. We can filter to a range. So this will filter down our list or an array of objects to any object that has a date between 2013 and 2014, January 1st. That's just a two-element array there if you can't see the brackets. You can also filter on an arbitrary function. So this function returns true if the value of the dimension is the string that we want, but you can do much more complicated stuff. And you can also unfilter things, so filter to everything on this dimension. So the dimensions, we can create multiple dimensions, and then if we filter on multiple dimensions, we'll get the intersection of the filters. Make sense? So we also can aggregate on dimensions. So the question is, once we've filtered on a dimension, or multiple dimensions, how do we get stuff back out? CrossFilter has the concept of a grouping, which is an aggregation. By default, a group on a dimension will simply return an array that includes an object for every value of that dimension, and then as the key, that object will have a key and a value. The key of the object will be the value of the dimension. The value of the dimension. The value of the object will be the count of how many times that value occurs in your data set. So if we wanted to count transactions per day, our dateDim was defined on our transactions CrossFilter, and we group that, and this will return an array of how many transactions happened every day. We can count transactions per month because groups also take accessor functions. You don't have to only group on your dimension values, you can group on a transformation of that dimension value. So in this case, we're taking the first 7 digits of the dimension, which is the year and the month, and this will return on the group of months and count by how many transactions happen in a month. You can do something like summing over groups of days. So there is an option in CrossFilter to, there are 2 functions. There's reduce sum and reduce count. Reduce sum takes another accessor function, but it accesses another value on the record. So if you remember going back to our original example, each record has a value, in this case 10. And instead of actually just counting up the transactions, we want to sum up the value of the transactions. So we tell it to reduce sum using the value field. And that will sum up all the values across the date dimensions. So some example queries. So the grouping creates a group, but it doesn't actually run the query. In order to run a query, you have to use one of these methods that I'm showing here on your group. So the cool thing about that is when you filter, so what you do is you define all your dimensions, you define all your groups, and then you define filters, usually in response to user interaction. When you define those filters, the CrossFilter will automatically update the values, more or less, of all the dimensions and all the groups. And then when you query them, you'll get those results back. So you can query, filter, query, filter, query, filter, and your results will change. So you can take a group that you've created, in this case our month group, and you can ask for the top month. This will give us this is kind of what the group object looks like. It has a key and a value. So say in the 6th month of 2013, we had 435 transactions. It's a count. If you remember back before, we did the date group, but we did the reduce sum to change the group to sum up on value. So this will actually give us the highest value under the current filter if we ask for the top date group. Apparently December 24th was a big one. And we could get all the months values under the current filter if we use the all function there on the group. Now this one you have to be a little bit careful with actually, because the all function returns the internal representation of the cross-filter groups. So if you change these, you'll actually screw up your cross-filter. So don't change them. It says that in the API documentation, but strange things can apparently happen. So you could, like if you did change this and then you applied or unapplied a filter, it would then apply that filter based on the value that you changed it from, and everything would all get out of whack. So don't do that. So the question is, what about speed? CrossFilter is incredibly fast. I'll show you an example in a couple minutes of cross-filtering over 300,000 records in real time in the browser. It's so fast because when you actually do a filter with CrossFilter, you start out by building your dimensions, you build your groups, and when you do that, it runs all the records through the group function. Each group has an addition function and a removal function, and an initialization function. So we may get into that if we have enough time, but for a count group, the initialization function returns that object structure that we saw where there's a key and a value. And then the add function will take an object from your initial array of data, and it will add that to the group that it's based on the group key that you've defined. So when you first build your groups, it will run all your data through the add function. Then you filter, and it will run all the data that doesn't match the filter through the remove function. And then you change the filter by just a little bit, expand it maybe, and it will only move those additional records through your addition function of your groups. So pretty much what you've got is kind of this incremental MapReduce concept internal to the groups. And what that means is that small changes, like the type of change that you'll get when a user interacts with a brush on a timeline and drags it, those small changes only result in a very small number of records being added or removed from all your groups. And so as a user drags a brush, that brush will actually move in real time with the user's movement, and all of your other dimensions can change along with that movement. So let's just show how that looks. There's a great demo of CrossFilter on the CrossFilter website. It's Square's GitHub. If you just Google CrossFilter, this is the first thing that comes up. So this is 230,000 records. It's a flights database for 2005 or something, I think. And we'll just filter on it a little bit. So we can make a filter. We can move it around. We can see everything change. Like as I move the mouse, there's not really any lag or delay here. These are pretty simple filters, but you can do quite complex filters actually, or aggregations actually, because of this type of incremental behavior. So I'm working on another project where we're doing extremely complex aggregations, and it's pretty much this fast. It's pretty amazing.
So does it just load all the representations of this data into memory and
that's right.
Operate on it? So
yeah.
How big is your data set that you're using in terms of like actual disk size?
This data set is about 5 megs. Okay. I did some stress tests in the lead up to this, and I was successful in loading about. I should actually just look at the exact data sets. Can
you pull up the Chrome memory?
Yeah, sure.
Or whatever.
We can do that.
I'd be curious to see how much,
yeah,
how much overhead.
So what I found was, where is this? Yeah, there we go. So what I found was with the timeline that do we have to turn this on?
The record button in the upper right.
So what I found with the timeline was that what was maxing out was actually not the ability of the browser to store the data. It seemed to be something in XML.
The size of the DOM or something?
It was the DOM, or it was the I just forgot the name of it. It was the actual request. So the request that was coming back was too big.
Sure.
And the browser blew up when the request came back. So I started splitting it up into little files, and actually CrossFilter has an add function where you can create your additional cross filter, and then as data streams in, you can keep adding it to the cross filter. And again, it's an efficient operation because it just runs it through the add function of all your groups.
That's pretty cool.
Yeah, so it's a pretty neat library. It's not perfect. Definitely under development. They do take pull requests though. So. Yeah, so it's about 60 megs right now.
Well, it did a garbage collection. It looks like it's way smaller.
Now it's only down to about 57, I think. So it takes. I mean, when you blow out a CSV into a JavaScript object notation, like it does take more memory.
Right.
It's not a very efficient way to store your data, actually. So one thing I've been thinking about is trying to get CrossFilter's internal representation to be more memory efficient. So if somebody wants to look at that, that would probably be a really good way to make it a lot more performant.
Well, and you know, on that note, so CrossFilter supports like loading a CSV file.
Yeah.
Right. So you don't have to have it in a JSON notation as a source data. It'll translate it.
Usually, what you do is it requires a JSON notation, but usually what you'll do is just use the D3 like CSV loader or something.
Right. It's not in CrossFilter.
Yeah. I've never actually seen CrossFilter used without D3, except in this example, like that I'm going to show you. But which is just like the console. Yeah, but I've never really seen it used without D3.
So CrossFilter requires D3 or
does not require D3. It runs on its own, so you can use it with any visualization library. Or, I mean, if you're not doing a visualization, if you're doing like tabular data or something, you can totally do that. Usually, if you're doing it in the browser, you'll usually want to be doing visualizations because, I mean, the strength of CrossFilter is this ability to actually have a user interacting directly with the data, whether it's in this kind of format or in a format more like what I showed you with Moritz with elastic lists, which is how I originally got interested in it, or a combination. So, but it's the filtering that is really key to why CrossFilter is powerful. If you're not filtering, then probably it's actually more efficient to just do your aggregation calculations on your own once when the page loads and then be done with it. It's certainly simpler.
So the business of selecting the range graphically on the screen, is that part of CrossFilter or is that
yours? This is a pretty standard bar chart in D3 with a D3 SVG brush behavior applied to it. So it's not much code, but it's D3. So what you see is D3, but the back end is CrossFilter. So I think it's getting a little late. So I guess I'll just jump to my kind of concluding notes, so that just some things to be aware of, and then we can chat more about this perhaps after the meetup if you're interested. I just have to find them now. So yeah, so a couple more things to mention. As I said before, and this is really important because everything will explode if you don't do this. Like if you get undefined values in your dimensions, really weird things start to happen and you don't know why. So that's always the first thing to check. Have you cast your values in your dimension accessors? They need to be either numbers all the time or strings all the time. No, nan is not happy. Undefined nan, null. I don't think null works either. I don't remember. Not good things. So it's a little bit finicky about that. They tried to actually make it automatically convert those into something that was naturally ordered, but that resulted in even crazier behavior because people were getting stuff that they didn't expect in their dimensions and they didn't know where it was coming from. Like lots of zeros or empty strings, and they were very confused. So they switched it back so it errors out and does very strange things.
So you're saying always cast to a string even if you have a number?
No, you can cast to a number as well. You just have to do like plus. The dimension would like return plus and then d and then the property name, and that'll cast to a number. So if it's not a number, it'll give you 0, I think. And if you want a string, then you do a string plus the property name. You can also combine properties or take substrings of them or whatever, but just make sure to cast it, like cast the result, so that you get something that's ordered. So the syntax, and definitely take a look at the API documentation, it's pretty decent. You can define your own custom reducers, so if you want to define an aggregation that's not a count or a sum, then you can do that by using this reduce function on a group. So you do group, and then you do .reduce, and it takes 3 functions. It takes a function that the first one is the initial function, and that just returns the object that you're using to count up things on your group. So usually that will have a key, which is where you keep track of the group value, like male or female for a gender dimension. And then it will have like a value, or if you're doing something where you're counting across a unique other dimension, you'll want to have a map where you store the values that you found already. Then you have an add function, which takes an object like what's returned by initial, which will be the object for the particular group that this record fits into. And then it takes the actual full record. So you have access to the complete record, and then you can do whatever you want with that. So you can also order your groups. So like I had top 1, top 5. You can also do bottom 1, bottom 5. But you want to be able to control the ordering. So you can pass in a function to control the ordering of your group. And then if that's not enough for you, there's group all. And that's just like group, except that this initial function doesn't create a single group object. It creates an array of all the group objects. And then that array of all the group objects is passed to each of these functions. That's important if you want to add one record to multiple groups, for example. You would need to be able to do that. So look into it more. There's tons of stuff to learn. But that's the basic idea of how CrossFilter works. If you find yourself in a web browser and you have tens or hundreds of thousands of records that you need to help people visualize and filter and understand quickly, then CrossFilter is pretty much the only library that I found that actually does that. So highly recommend it. Again, you can find me here at Jewett, and there are a few links. I'm going to post this presentation, I think, to the group. Can I do that? Yeah, so you can find those in the group. And that's it.
Can you run it without a browser, like server-side JavaScript?
It does. It works server-side. The thing is that the filters are integral to the actual CrossFilter. So every CrossFilter has a state, which is made up of the dimensions that you define, the groups that you define, and the filters that have been applied. So it doesn't really make sense to have a multi-user CrossFilter, because different users will be filtering on different things. So each one would have to have their own CrossFilter. So I think usually it probably makes more sense to run that on the client side, but you can run it on the server side. Like you can definitely. I think they actually have a node module.
I wasn't thinking that way. I was thinking doing MapReduce job with it.
Yeah, sure.
So
it's possible.
Using it instead of.
Yeah, you could theoretically do that. Definitely. I think Mongo has kind of a similar concept of how to do aggregation, so that would be an option to look into as well. Any other questions? Great. Thanks, everybody.
Thank you.
Yeah.